Okay, now we're getting into solving exponential and log equations. So this will stretch your brain too, but we're going to be using the things that we've done in the previous lessons. So, as always, if you feel like you can master, once you've gotten the hang of one question, and I go on to another practice question of the same or similar type, pause the video and make sure you can try it on your own first. Okay, so this is pretty straightforward. I don't really need to use a log property. I can change 9 into 3 squared, and I can tell you that the exponents have to be the same, so the answer to the question is 2. So in this case, I didn't need to use any log properties. In the future, what we will be doing is we'll be rewriting things into a logarithm form. And if you'll notice what I did there, and maybe I did it too fast, I changed it into its log form, just like we've used the boxes before. Now, this would only be something I would do if 9 were not such a nice number in relationship to 3, but and then I would have used the change of base theorem, log of the argument over log of the old base, and then I would have just typed on a calculator, okay? But in this case, we didn't need to do that, okay? But here we do, okay? Because nobody knows how to write 5 as a power of 2, and so that's the first thing we're going to do. We're going to go log of the, change it into its log form. So we're going to fill in these boxes. And, of course, the base is 2, right? We got that part. The exponent, which is what log equals, is x. That leaves you with one thing left, 5. And so then we can change this left side into something our calculator can handle. Log 5, log of the argument over log of the old base. And we chose base 10 because we can type on a calculator, right? And we can come over here and turn that on, and log 5 in parentheses divided by log 2. And so we know that 2.32 is approximately what we're dealing with. 2.32. Now, how can I double check to make sure I'm right? Okay, I think it's 2.32. So here's how you double check. You take 2 to the answer power. Now, it uses the nasty decimal that I didn't want to write down, and we should be getting 5. Did we get 5? We did get 5. Okay, so we know we're right. And I know they say round to 4 decimal places, but remember, I've told you time and time again that the rounding isn't the biggest issue in my life, okay? Seeing all the work that you're doing here, and then watching, and then knowing that you're typing it on your calculator, that's what I'm hoping for. Okay, now, a little bit of a stretch with this one, but I think we can handle it. All right, so this isn't too bad. We could change that into 5 squared, right? 25 into 5 squared. So what does that mean? Well, you have 5 to the 5x on one side, and 5 to the second on the other side. So that must mean this exponent and this exponent are the same. And if that's true, then you can easily divide by 5 and find out your answer is 2/5. And yeah, that's the same thing as 0.4 for you decimal fans out there. But that one did not require me to use logarithms because 25 was nicely changed into something based on 5. Now, I will need logarithms for this one. Okay? So, try this one on your own before you watch me do it. Okay, so we've got a base of 5. The exponent is 2x. And the last thing left is 19. Now, I have no idea how to write 19 as a power of 5. So I'm going to use my change of base theorem. Okay. And log 19 over log 5, that's a number. Let's find that number. Log 19, oops, can't type, 19, end parenthesis, divided by log 5, end parenthesis. So that's my ugly number. And then, of course, you know from what you saw earlier that we had 2x on the other side. So I can easily say that I would divide by 2 to get my final answer, 0.915. Okay, so I would divide by 2, divide that by 2, and we end up with, what did I just say? Not 0.915. Man. And if you want to double check your answer, 5 raised to the, and I'm going to use parentheses, 2 answer power. So that's basically multiplying the 2 times the x. And I better get 19, and I do get 19, so that's good. Okay, so let's solve this one. I need to change it to its exponential form. Okay, something to the something power equals something else. Okay. So, what's the base here? The base is 10. The exponent, well, the exponent's on the other side. 0. That leaves you with one thing left, 17 minus 4x. Okay, so, what can we do with this? Well, 10 to the 0, that's a 1, right? That's nice. And then we can subtract 17 from both sides. That gives me negative 16 equals negative 4x. And hopefully you're going to think divide by negative 4. So we get an x value of 4. And that's true. And you can always go back and if you want to check your answer. Since this is base 10, this would be easy to check. 17 minus 4 times 4. And you better end up with 0 as your answer. And you will. Alright, next up, we have, what my question to you is going to be this. Is this side a single log? And you better be saying no. So we need to make it a single log, right? So that's my first step. So since I see addition right there, that means I'm going to take the 3x and the 1x and I'm going to multiply them together. And that's going to create log 3x squared equals 8. So now we can solve this question by changing it to its exponential form. Here, I'm going to scoot over since I got all this other space. Something to the something power equals something else. So, what goes in those boxes? Well, the base, right there, right? Remember, whenever you don't see it, you know it's a base of 10. The exponent, which that's over here, right? That's on the other side. Logarithm means exponent. And then the only thing left is 3x squared. Now, 10 to the 8th, folks, that's a big number, right? Because it's got 8 zeros. Let's see, do I have 8 zeros? 3, 6, 8. So 1. That's 100 million. Now what do we do from there? Yes, we do divide by 3. Yeah, come on, clear. 10 to the 8th. See, that's that big number. Divided by 3 equals. Come on, equals. What's going on here? There we go. So, got a lot of numbers there. And then, of course, the last thing that's going to happen in this question to get rid of the square is take that square root. So, if I pull that calculator up on screen again, I can take the square root of the answer. And I end up with my final answer here of 5,773, 773.5, approximately. So once again, do we have a single log on the left side? No, we do not. So we need to focus our attention on making it a single log. We see that it's subtraction, so that means we're going to take the 35 and the 2x and make one logarithm, and that's equal to 1. All right? So now we're ready, as a single log, we're ready to set it into its exponential form. So, what's the base? Yes, once again, since it's not written there, it's 10. If it is written there, then make sure you use whatever that number is. Exponent sitting on the other side, and so that means we've got 35 over 2x that goes in the remaining box. Okay, so if I write this out a little bit nicer, I have 10 equals 35 over 2x. Okay, anything can be divided by 1. We do have a proportion set up here, so we can cross multiply. So that would be 20x equals 35. And then we could divide by 20 on both sides. And so we end up with x being 35 over 20. 35 over 20. What's that reduce to? Like 7 over 4? That's like 1.75. So, I wouldn't care if you put 7 over 4 or 1.75. Either one of those would work. Make sure you pause the video, try the problem. Okay, this one already is a single log, so we can change it to its exponential form immediately. Something to the something power equals something else. Okay, so base is 16. That's right there. The exponent's on the other side, 1/4. And that leaves me with 4x minus 1. Okay, so 16 to the 1/4. Now, I hope that you remember from our previous chapters that that's the 4th root of 16. Don't think square root, the 4th root, and the 4th root is 2. And then we can do what we normally would do. Add 1 and divide by 4. 3/4. Okay, question 9. Solve the following logarithmic equation. Be sure to reject any value that is not in the domain of the original logarithmic expression. Now, what in the world would that mean? Well, log base 4 of x looks like this. We covered that in a previous video. All of the basic log functions look like that. So if we ended up getting, and the domain of that function is greater than 0. It can't be equal to because it can't touch the vertical asymptote. So if we ended up getting a negative number, we would have to get rid of that answer. Okay? I don't think we will have that problem here at all. Is that highlighting those things? Okay, good. Okay, so this particular equation needs to be changed into its exponential form. Something to the something power equals something. So let's see what we have here. The base is 4. The exponent, well, that's on the other side. That's 3 because logarithm means exponent. And that's equal to the last thing, in the which is x. 4 to the 3rd is 64, so we're done with that question, right? 64 equals x. That wasn't a very complicated one. We did not end up with a negative number, so we didn't have to do any of that rejecting stuff that they talk about. we very rarely would we come across that, but there are situations where it happens. I don't think we'll see many of them. Okay, so same type of situation here. You try. Okay, put it into its exponential form, see what you get, and then solve it. So make sure you're trying to pause the video, practice, and then you do it. And then you can watch the video to see if you're right. Base is 5. Exponent is -3. And what it equals is the remaining part, x. Well, 5 to the -3rd, that's the same thing as 1 over 5 to the 3rd. We talked about how the negative part causes it to flip over. And that would be 1 over 5 times 5 times 5 is 125. 1 over 125. And it's not a negative number, so I don't have to worry about that whole rejecting idea. Okay. Similar type of problem. This to this power equals this. Try it on your own first. Okay, so you've tried it on your own already, and the base is 64. The exponent is 1/3, and the remaining part is x. Now, what does a 1/3 exponent do? Well, I need you to remember and not to forget that that means the cube root of 64. The cube root of 64 is 4. Now, this, just so you're aware, this logarithm function right here has been moved 3 units to the right. So it's got a vertical asymptote at x equals 3. And, oops, that's bad looking. But, right idea. And then it goes like that. Something of that effect. Well, so anything, this would have a problem with it if we had anything 3 or less, right? The domain here is greater than 3. So if you got a value that was 3 or less, we would have to throw it away as a bad solution. So let's see what happens here. Something to the something power. Now, the only reason I can change these is that we have a single log. And every time I'm changing it to its exponential form, I should have been asking you guys, is this a single log? If it's a single log, then yes, you can change it to its other form. The base is 2. The exponent is -2. What's it equal to? X minus 3, the argument x minus 3. Well, so 2 to the -2, that's really 1 over 2 squared. Which is 1 over 4. And then on the other side of the equal sign, we have x minus 3. So, of course, we're going to add 3 to both sides, and we end up with x equals 3 1/4, or 3.25 if you're a decimal fan. Those are your, and of course, that fits inside the whole greater than 3 scenario. So 9x plus 9. That's hard for me to show you, and for it to make any sense. I guess I could write it as 9 times x plus 1. Which would help you see that it's been shifted 1 to the left. So it's got a vertical asymptote like this, and it does something like this. So the domain would have to be greater than -1. But, you know, I don't think we're going to have issues with these. We're not going to end up running into problems. So, is it a single log? Is this a single log? And it is. You don't have multiple logs that need to be combined together. You don't have any exponents that need to be brought down as coefficients. It is a single logarithm, so we can change it to its other form. So the base, yep. If you're trying this on your own, make sure you're pausing, trying, and see what you get. And then the exponent is 2, and the remaining part 9x plus 9. And so we've got 4, and we will take away that 9 right there. Trying to speed this up a little bit. So that would be negative 5 equals 9x. And divide by 9, divide by 9. We get x equals negative 5/9. Now, negative 1 is the cutoff. So this was kind of close, right? It's in there somewhere, close to negative 1/2. But it is still inside the domain of the function, so we're okay. I'm only drawing those pictures to help you understand what it looks like.